So my PowerPoint didn't sync for today, so there's no PowerPoint. But basically, the three things we're going to talk about is quiz 3. We're going to talk about assignment 7. Assignment.
Whoa.
Yep.
We haven't even finished assignment 6.
Yeah.
I haven't even started assignment.
We're going to talk about string representation.
Just leave and never come to class. Just like
You want me to just cancel class for the rest of the semester and be done?
Please.
give us the assignment.
I'll give you $50.
Some of us are running on like 2 hours of sleep because of blackouts.
Oh god.
Maybe you shouldn't.
Because
be
that's a
playing
valid.
horrible game.
I agree. Should not be playing
Hey, I thoroughly enjoyed 1 and 2 very much.
Yeah.
Okay, whatever. Yeah. Okay. So, talking about quiz 3, assignment 7, string representation, and array modification. Hey. Stop. Everybody cares. So, first thing about quiz 3. So, I probably will end up giving you another chance to do quiz 3. I'm going to change the numbers around a little bit, but I will post that out soon. Odds are I'll get it done, I'll get it up and running tomorrow, and you'll have from tomorrow to Saturday to take it again. Because nobody scored better than 8 out of 10, so, or 9 out of 10, yeah. Are we on quiz 3 now? I think we're on quiz 3. Well, whatever the quiz we did last was, I'm pretty sure it was 3. Okay. So one thing to keep in mind, yeah. I'll probably have it up tomorrow sometime, and then I'll have it open from tomorrow until Wednesday or so. So on quiz 3, so one thing that's really good to keep in mind is if you're having trouble keeping track of the loops, you should get yourself a piece of notebook paper or do it on a notepad document. Just open that up and actually run through each part of the loop. So when you're running through your loop, you'd say I equals 0, and when I equals 0, it's going to print 1 star. When I equals 1, it's going to print 2 stars or something like that. Or you could track it like I equals 0, 1, 2, and then you can also track it below and say that we have a total of 3 stars, and we're printing it like that. So just keep in mind that I really want you to understand how the for loops operate. So you should know that if I is less than 10, that the last thing that I will ever equal is 9. So when I is less than 10, we only ever equal 9. We start at 0 and we go all the way up until 9. So that's quiz 3. Any questions about the content I covered on that you'd like me to cover in more detail? The quiz 3, how many stars, how many numbers, highest number, lowest number. Yeah.
And that's outside of class?
Yeah, that'll be outside of class again.
Do Sunday?
It'll be due like Wednesday or so. I don't have it up yet, but.
Thanks for not making it do Sunday, because that's working up Wednesday.
And that's my birthday.
Okay.
Make it do Sunday.
So Nate, you had some questions about assignment 6. Anybody else again? Just. Oh, after class. Anything specific that you want me to cover? Concepts right now?
I was mainly thinking adding up all the numbers in the array.
Okay. I'm going to cover a couple examples of traversing arrays in array modification, but I will come back and I'll think about talking about some. So, with assignment 7, I'm not giving assignment 7 today, but I did want to talk about what the basis of it's going to be. So with assignment, I want you to play blackjack. Yay. So, a couple things that you're going to need to do in this assignment. You are going to need to shuffle a deck. No, this is going to be definitely 100% out of class assignment. So you're going to need to shuffle a deck and represent it as an array. You're going to need to be able to take number from array and print card, suit, and rank. You're going to need to manage or track user chips. You're going to need to prompt user to hit or stay, ace high or low, and things like that. So if you're not familiar with the game Blackjack, I definitely think about how you do these things, 11 through 15. Those are a couple things that you'll have to do in this assignment. If you're not familiar with the game, I'd take a look at the Wikipedia page and just familiarize yourself with how the game would actually be played. So a couple things I'm also going to do, I forgot about this one, so we're going to play with n players. So you're essentially going to need to track all of this information. So tracking how much the user has in chips, tracking what their current hand is, tracking what the deck currently is at. And so just keep a couple of those things in mind when we're working on that. So again, I'm not giving you that today. I'll probably release the exact specifications for the assignment on Monday, but think about that. That's going to be assignment 7. Probably 2, 2.5 weeks.
4 weeks. Like 2 weeks after 7 weeks.
Approximately. It'll probably be due not this coming Friday, but the Friday after that, so 2 weeks from now. This coming Wednesday.
Well, like a week and a half to work on it.
Yeah. So, string representation. So remember that we can declare a string like this in C. We can say char my string equals hello. And what that will give us with is it will give us at position 0 an H, at position 1 E, that's not an E, at position 2 an L, at position 3 another L, and at position 4 an O. Now also in C, what happens when we declare a string like that is we'll also have a position 5, and remember that is the \0, which is the null terminator. So just remember that when we're printing strings, when we're passing strings to puts or printf or puts will start at position 0, and we'll print this character, it'll go to the next position, print that character, so on and so forth, until it reaches this null terminator. So it will print all the characters up until it sees this null. So one of the things we can actually do is we can have this null here, but we can also go back to another position and we can print, and we can just have one null right here. So this will only print HE because we essentially just stop the string midway through. So I'll go through and do this quick example here. So remember, if I just say puts str, that will just output hello. But let's say I go and I say str at position 2, which 0, 1, 2 equals this null terminator, then we're only going to print 0 and 1. So we only print position 0 and 1 because after the puts function sees that null terminator, it stops printing characters. So just remember that if we want to change exactly what's printed in our strings, we need to change where the null terminator lies. So we can change positions of that. We can put that in position 3 instead, and that will print HEL instead. So HEL. So one thing to keep in mind. So looking at a little bit more about how strings are actually represented, I talked about it a little bit, but I want to go back and do a little example showing you exactly where each character is. So I'm going to make a function called rep. It's going to take a string or character array or string and a size. Now we can again pass. So when we want to pass a character string or a character array to a function, we just say str. We don't have any brackets when we're passing it into the function. So remember, no brackets when we're passing into the function. And then in this case, we want to specify the length of this string. So we have 0, 1, 2, 3, 4. So that's a total length of 5. So this we'll call the rep function. Now, what I essentially want to do inside the rep function is I want to print out what position we're at and what character is at that position. So in order to accomplish that, the first thing we're going to need is an index variable. So I'll say I, and I'll say for I equals 0, I is less than size, plus plus I. So what this loop is going to do, it's going to start at position 0, and it's going to loop up until size, which is 5. So effectively, we're going to have 0, 1, 2, 3, and 4 that will be potential values for I. So I'm just going to write a printf command that will print which character is actually at each position. So you'd say %i, %c, then a new line, then I give it I, and then I give it str at position I. So this function will loop 5 total times, and will print the character at position in the position of the loop index. So we can see that that is just a different way of looking at our character string, our character array, just giving you another example of how it's actually represented. And each of these are just individual characters. They're just grouped into an array. So any questions more about strings and things like that?
It's not about strings, it's about arrays. How will we print
What do you mean? Okay, so here's what I'll do. I'll make 2 different representation functions. I'll make another representation function which takes an integer array. So rep I. And that will take int data of int size. And then my loop would look almost exactly the same. So I just need my index. I is less than size. I just need to change my printf command around a little bit. And instead of saying %i, %c, I'd say %i, because we're working with integer data. And then I'd say I, and I'd say data at position I. And I'd also drop a new line in there. So let's say I had int my array equal of size. Well, we'll limit the size in this case, and we'll use this declaration instead. 1, 2. Well, let's make it all 5s. So that array is 4 long, so we'd say you change this to rep c because we changed that function name. We'd change this to rep I, my array, and that is 4 long. So that would also print the index of our loop and then what's stored at that position in our array. Does that kind of answer your question, or is there something else?
Yeah, but we can't put like this puts. You said like if you wrote puts STRs, it would print below.
Mm-hmm.
Can we do that with integers too?
No, so the only thing that the puts function does is it takes a character string like this. So that's the only thing that we can pass to the puts function. All other data has to be manipulated by us and and we have to work with it different ways.
So we have to use a for loop to print an entire array.
Yeah, if we want to print an array of integers, we definitely have to use a for loop. All right, so next couple things I want to talk about are different array modification techniques. So the first one I want to talk about is, let's say we want to initialize array. The second one I want to talk about is printing array. We already did that one, so I probably won't talk about it again. The third one I wanted to talk about was adding n to all elements. Next one I want to talk about was inverting, gating all elements. Then I also want to talk about with character strings how we would capitalize and lowercase a string. So we'll get started with initialization of arrays. So let's say I have an integer array with with 5 positions. That's a good number. So just to keep things straight, I will go and I will say size equals 5, and then I will use size for my size instead. So I'm going to write a function called init, and what it's going to do is take an int array in size. And what it will do is it will loop through that array, or loop through the array, and it will set each position of the array equal to a value. Now, what I actually want to do is I want to specify the value that I want each position of the array to be set to. So I'll add a third parameter to my function. I'll call it value, int val. So what I'll do inside our for loop body is I'll say r at position I equals val. So back in our main function, what I could do is if I wanted to initialize my array entirely to, let's say, 10, what I would say is init my array of size, and then I want to store 10 in it. Just so we can keep track of what's going on, I will quickly write the print function. And size. Just so we can see exactly what's in our array. So we'll init, and then we'll print. Made a few mistakes here. Yep, left off my semicolon on this line. So we can see that that function will loop through our array and set each value to 10. We can change that to be whatever value we want to. Let's say we want it to be -20. We can do that too for some reason. Recompile it again. And that will set our entire array to -20. So that's the first example. So that's initializing an array and printing that array. So the second thing I want to do is add a number to all elements. So we'll set this back to 10. So let's say we wanted to add arbitrary number to every single element of our array. So let's just write void add. Again, we need to pass in our array. We need to pass in the size of our array, and we need to pass in the value that we want to add to each element of the array. Then we need an index and a for loop, just like before. So then in the inside body of our for loop, all we would say is array at position I plus equals 2. And what that will do is it will add 2 to every single position of the array. So to call it, we pass in my array, pass in size, and we pass in 2. Sorry, I need to change this here. We don't want to add 2. We want to add the value that we pass in. So our third parameter, val, which we specify right here. So we're going to initialize our array to 10, print it out. We're going to add 2 to every single position, and then print it out again. So we can see that every single position of the array has had 2 added to it. I'm going to add one more initialization function. I'm going to write a function which initializes an array to values between x and y. So you call init, you pass an array, you pass in size, you pass in where you want the first value of the array. So let's say I wanted an array of size 5 between 5 and 10. So I'd pass in 5 and 10, and it would initialize my array to at position 0 it would be 5, position 1 would be 6, at position 2 it would be 3, no, 2 it would be 7, sorry. So I'll try and explain that better once I get to it. So we'll call it init xy, we'll say int array, int size, int x, int y, and then we need a for loop like before. But we don't actually need I in this case. So what we could say is for, and then skip the first component of our for loop by saying semicolon, and then saying x is less than or equal to y plus plus x. Now what we could say is our, never mind, that's wrong actually, because we need to reference the first position in our array. So we'll go back and I will actually write the loop like I did before. So I'd say int I for I equals 0, I is less than size, plus plus I. And then we say r at position I equals x. And then we will increment x every single time. So actually I'm going to drop the y component of it, because since our array is of a specific size, we can't actually make our array any bigger than that size. So I will just say x. So x is our starting value though. So let's say I want to, I can take an array and I can reinitialize it. So I can say init my array size, and let's say I want to start at 10, and I'll print off. And its size. So I'll print my array and its size again. Alright, so that didn't do what I wanted to do. It initialized my array entirely to 10 again. And that's because I did not say init xy, I said init. So I need to go back and I can say 10 again, but my function does different things now in this case. So you see now that my array starts at 10, it goes 10, 11, 12, 13, 14. So just as an example of our add function, I'm going to go back and I'm going to delete everything except for the init xy line and the print, and I'm going to say add my array size 2. So we'll add 2 to every position of the array again, and we'll print it out again. So we can see that this is the first time we print the array, and this is the second time we printed the array, and it will just add 2 to every single time. So that's adding n to all elements. The third thing I want to talk about is negating or inverting every element of the array. So we say void invert int r int size. So just like before, we want to loop through every single element of the array. I'll just copy all this down here. And then I would say r at position I equals r at position I times -1. So what this will do is, if it's negative, by timesing it by -1, it'll make it positive, and if it's positive, timesing it by -1 will make it negative. So let's look at this. I'll delete my add function there so we can see this easily. So we can see that that inverts all of the numbers of our array. So I'm going to go back here, and instead of saying init, I'm actually going to give literal values that I want in my array. So I'm going to say -1, +1, -2. Oh yeah, sure, we'll do that. -1, +1, -2, +2, and 4. 1, 2, 3, 4, 5 values. One, two, three, 4, 5. Oh. So what's happening here is it's not going to let us do that unless we specifically tell it how big it should be or leave off that size entirely. So we can see by default it prints -1, 1, -2, 2, and 4. But then after we call the invert, it inverts the positivity or negativity of all the numbers. So instead of saying -1, it says 1. Instead of saying 1, it says -1. Instead of saying -2, it says 2. 2, -2, and 4. So another function to manipulate things. So the final two I want to talk about are capitalize and lowercase. So in order to do capitalize and lowercase, I'm just going to comment out everything that we've done here so far. So capitalize and lowercase are working with strings. So I'm just going to have make a character array, str, and then set it equal to hello. So I'm going to write a function which takes each letter and checks to see if it's lowercase, and if it's lowercase, it will replace it with a capital letter. So I'd say void caps, pass in char, str, and then int size. So what we're going to do is we need a index, we need to for loop, I equals 0, I is less than size, ++I. And this is where the fun starts. So what I'm going to do is I'm going to have a intermediate variable which stores the character that we're currently working on. So I'm just going to say char a equals str at position I. So whatever character is at position I will be stored inside of a, just for temporary use. So to detect if a character is lowercase, we can say if a is greater than or equal to lowercase a, and a is less than or equal to lowercase z. So if both of those conditions are true, then we know that the character is lowercase. So if it is lowercase, we need to determine its position inside of the alphabet. Now, in order to do that, we'd say int position equals character minus a. Now, since I have all these a's going on here, I'm actually going to change my variable name to be x, so we're not getting confused between when I'm saying x and when I'm saying a. So remember that each character value in C is just an integer number. You can look up their actual values on a table on the internet. Just search for ASCII table. So what this is going to do is it's going to get the value of our current character and it's going to subtract from it the character or the value of the first letter of the alphabet. So let's say we had, we're looking at character B. Subtracting A from B is going to give us 1 because there is one difference between A and B. So I'm actually going to do something a little bit different here. I'm going to move my position variable outside of my for loop, or outside of my if statement. So now that I have all of this, so I have the position in the alphabet of that letter. In order to replace so after we have the position, we need to calculate what the uppercase equivalent would be. So we need a second character, y. We would say y equals uppercase A plus position. So recall that if we have character B stored inside X, and B minus A is going to equal 1, then A plus 1 is going to equal B. So in that case, if X is character B, then Y will be uppercase B in this example. So then what we would do is we would say str at position I equals character stored in variable y. So theoretically, if I know what's going on here, this will capitalize our string entirely. So we need to pass an str, and we need to pass in 5, which is the length of our string. 1, 2, 3, 4, 5. And then we'll put str. Yep. Cool, thanks. So I didn't change my A up here. I need to change this A right here to be X instead. So that will take my string and make it capitalized hello. So fun, fun, fun. Does anybody want to take a shot at doing the lowercase function? So if I was to give you a lowercase, or give you an entirely uppercase string, who could tell me what I need to do in order to make it lowercase? So I'm going to copy this down here, and then I'm going to ask you what you need to change to make it lowercase. So I'll change to lower. So what would we go about changing here? Nope. That's the start. So the first thing I want to do is change this to be capital A and this to be capital Z. And what that will do that will detect if the character is currently uppercase. Not quite.
You should put y equals lowercase a.
Yeah, that would be something we need to do. But there's one other thing we need to do. We got one thing left we need to do. Yep, we need to change this one here on line 75 to be an uppercase A. So that should be everything we need to do to change this function, the caps function, to make a lower function. Which I'm probably not right, but we'll see. So we can see that that will take a uppercase string and make it a lowercase string. So just a couple other sort of fun examples of things we can do with functions and manipulating arrays. So just a couple things to keep in mind. So I think that was all I had for array modification. There was another one that was interesting, but it was on my PowerPoint that I don't have. So did you still want me to think more about sum, or did you still want me to talk more about sum? Or did this kind of help you get there a little bit more? So it's the code for doing it. So let's do this. So the code for sum isn't that hard. So considering that we have, let's say R is our array, size is our size. So one thing that we're going to need is another variable to store the sum. So we were going to say sum, that is our sum. So we'd say for 0 to size, I'm going to sum, or I'm going to add array at index to sum. And that's essentially our pseudocode for finding the sum of our array. There's a lot of implementation details that you'll need to fill in there, but that's kind of what I want you to do. I want you to know how to use the C language to solve a problem like this. So it's really basic. You just get each value at each position of the array, and you add that value at each position to the sum variable that you're maintaining. And then at the end of your function, you'd say return sum. So that's all I have for you today. Any other questions that you want me to cover?
Is the assignment we're working on right now due next week?
It's due this coming Wednesday. So today is the 6th. The assignment is due on the 11th. So I'd highly recommend that you finish it before Wednesday, because there is no school on Wednesday, and because it's Veterans Day.
Oh, no. I'm down.
All right.